Hello! In this video, we're going to talk about an introduction to differential equations. So let's just start with what are differential equations. Differential equations are equations that involve ordinary or partial derivatives. So here we just have ordinary derivatives, or total derivatives, for our two equations. dv dt is equal to minus 3 times t, or d squared x dt squared is minus 4 times x. The solutions to differential equations are functions rather than numbers. So, for instance, the solution to the first differential equation is v of t is equal to minus 3/2 t squared. That's one solution, at least. A solution to this other differential equation might be x of t is equal to cosine of 2 times t. There are techniques for solving differential equations. These techniques have names like separability, exactness, slope fields, and so on. And we'll talk about all of these in detail as we go. But I just want you to know that there are various techniques that we will be using. Also, differential equations show up everywhere in physics. In particular, the rate of change of the velocity of the car is decreasing with time. That statement is a physics statement, and it's a differential equation. A statement you might encounter in using Newton's laws would be the acceleration of a mass on a spring is equal to minus 4 inverse seconds squared times its position. So you'd get a differential equation like this. I want to talk a little bit about the terminology of differential equations. There's three types of terms I want to discuss: the order, the type, and solutions. About order, we say that a differential equation is, say, first order or second order, or more generally, we define the order of a differential equation as being equal to the highest power derivative in the equation. So first order derivatives have first derivatives. Second order differential equations have second derivatives. In this example, this is a first order differential equation because I have just a first order derivative. Why should you care about describing the order of a differential equation? Well, a differential equation of nth order has n arbitrary constants in the general solution. So for an example here, we had a first order differential equation, so there should be one arbitrary constant in the general solution. So the general solution would be here, v of t is equal to minus 3/2 t squared plus c, where c is some arbitrary constant. So we know that this is a general solution and that that's all the arbitrary constants that we'll have in that general solution. If you don't believe me that this is a general solution to this differential equation, you should check it and see that it actually is a solution for all possible c values that you could choose, as long as c is some constant. Let's talk about the type of a differential equation. And by type, I'm essentially meaning linear or nonlinear. So linear versus nonlinear differential equations depends on the power of the function you're solving for in the differential equation. So in the examples in the box here, the function we're solving for is y as a function of x. And so we want to know what are the powers of y in this equation. And we can see for the linear case, we just have linear powers of y on both sides of the equation. For the nonlinear case, on both sides, well, on the left side we have a linear power of y, because it's just a first derivative of y. On the right-hand side, however, it's y squared. So we would say that y squared is nonlinear, and so this particular differential equation is nonlinear. Why should you care about linear versus nonlinear? Well, it turns out linear differential equations are almost always able to find solutions, and they're usually pretty easy to find. But nonlinear differential equations are actually much more difficult to solve and are harder to find solutions for, except in special cases. Finally, I want to talk about the terminology of solutions, in particular the ideas of general solutions, particular solutions, and the initial value problem. So let's look at our example that we had before. dv dt is equal to minus 3 times t. We said that was a first order differential equation, and it has one arbitrary constant in the general solution, so we actually already have a term here, the term general solution. And what we mean there is the most general solution to a differential equation is the solution that has as many undetermined constants in it as the order of the differential equation. So this is the first order differential equation. This solution here has one undetermined constant, c, and so it is a general solution to this differential equation. An initial value problem is the differential equation that we're interested in together with an initial condition. You generally need as many initial conditions as there are the order of the differential equation. So this is a first order differential equation, so we have only one initial condition, that v at t equal to 0 is equal to 0. So the differential equation together with that initial condition is called the initial value problem. And then finally, the particular solution to a differential equation is a specific version of that general solution that solves the initial value problem. So, for instance, for this general solution, if I want to impose the initial condition that v at t equal to 0 is 0, so I plug that into my solution, and I find that the constant c has to be actually equal to 0 in this case. And so my particular solution that solves the initial value problem is v of t is equal to minus 3/2 t squared. Note that the particular solution actually is unique. There's only one solution to the initial value problem for a given differential equation, for any given system. Okay, so I hope that gives you a brief overview of differential equations.